Today, NASA is inviting you to participate in the next monumental journey of a lifetime. A journey to extend the frontiers of human exploration. Gaze across alien landscapes and see our sun rise over new horizons. Nearly 3.8 billion years ago, prokaryotes, the first known simple-celled organisms, appeared in Earth's oceans, becoming the harbor for new life in our solar system. Today, NASA's Mars orbiters, rovers, and landers have discovered that the red planet could have had water on its surface early in its history too. But something happened. The surface water and atmosphere on Mars were lost. Did life once evolve on Mars and suddenly cease? Could Earth ultimately experience the same fate? To find out, astronauts will need to make the trip to Mars. However, the technological and biological knowledge NASA needs to make the trip safely does not exist. Yet. Today, NASA's fleet of robotic scientific explorers at Mars are paving the way for human exploration. In 2012, NASA landed its largest and most sophisticated rover on Mars. Its name is Curiosity. Its purpose is to determine if past conditions on Mars could have supported life and to investigate cosmic radiation challenges. These investigations will be useful in designing spacesuits and equipment to protect the astronauts while traveling there in the future. This journey will take about 9 months, a long time to live in a spacecraft before reaching Mars. Astronauts will face many biological and cosmic challenges. Without Earth's gravity, astronauts will experience a decline in bone density, reduction in muscle mass, changes in vision, and other physiological and psychological effects. Getting to Mars is hard, but NASA is committed to solving the challenges. NASA is practicing living in space on the International Space Station. This world-class national laboratory houses a crew as it continuously orbits Earth, testing various technologies and human capabilities in low Earth orbit. Astronauts test air, food, water, and waste systems, and astronauts are now making one-year visits to the station while testing and refining reliable deep space systems. To make the trip, NASA is going to need a larger, more powerful rocket system than has ever been developed in the space program. This transportation system is in production and has 3 components: an advanced spacecraft called Orion to house the crew, a powerful expandable rocket space launch system, or the SLS, and a modern spaceport with an assembly plant and new launch site, which are currently being built at Kennedy Space Center in Florida. All 3 components of this system have to be ready at the same time and must fit together perfectly. The Orion is unlike any spacecraft that has ever been built. It will hold 4 astronauts and take humans to a variety of space destinations. In 2014, Orion launched for the first time from Kennedy Space Center on a substitute standard rocket. The flight tested critical systems and the 16.5-foot heat shield that will protect the crew from the searing heat during re-entry. The spacecraft impacted Earth's atmosphere at 20,000 miles per hour, with the heat shield reaching a blistering 4,000 degrees Fahrenheit. Despite the scorching temperatures outside, the interior maintained a comfortable temperature around 75 degrees.
All engine running. Liftoff.
The next time Orion takes flight, it won't be orbiting Earth. It will orbit the Moon, and Orion is going to need a more powerful ride. It has been 40 years since NASA's built a rocket that takes humans beyond Earth orbit. The new SLS will have a large version that can send a habitat and supplies to Mars' orbit and surface in advance of a smaller version that will take the astronaut crew. Right now, we are working toward the first integrated test flight of Orion and SLS. However, the most powerful rocket in the world needs a modern assembly facility and heavy-duty ground support. The ground systems team at Kennedy Space Center is working hard to redesign and rebuild the launch pad, flame trench, and pad structure to withstand the incredible 9 million pounds of thrust generated by the SLS. Landing on Mars will require advanced technology and entirely different engineering. Mars lacks the atmosphere to land vehicles with friction and parachutes, as done on Earth. The heavier landers of tomorrow, some as large as a 2-story building, will require new entry, descent, and landing technologies and new woven heat-resistant materials. NASA is testing a new low-density supersonic decelerator that is equipped with a drag device deployed at supersonic speeds. Once on Mars, astronauts will have to live off the land, as pioneers have done on Earth. NASA will need technologies that can filter oxygen and recycle water from the surface of Mars, and will need to develop complex environmental control and communication systems to enable critical capabilities required to extend human presence onto the Martian surface. To explore Mars, astronauts will also need technologies for transportation systems that can move humans and cargo across tens of millions of miles, as well as small mobile power plants to provide energy. In preparation for Destination Mars, astronauts are going to need to practice working in deep space. In parallel to all of these technology developments, NASA is now planning a robotic spacecraft to journey into deep space to capture a large boulder from an asteroid. This colossal space rock may contain water, carbon, methane, sulfur, or even iron. Using advanced solar electric propulsion, the spacecraft will move the massive asteroid boulder safely into orbit around our Moon. The mission, Asteroid Redirect Mission, or ARM, is a key capability demonstration for a future Mars barge that may deliver supplies and a habitat prior to the crew's arrival. This mission also lays a piece of the groundwork for a potential planetary defense system against asteroids that could threaten Earth. Before returning the large asteroid boulder to lunar orbit, the spacecraft will perform a maneuver to demonstrate the capability to alter an asteroid's path. What happens next is right from the pages of science fiction and is a critical step towards testing technologies that will enable us to explore Mars. Humans will venture deeper into space than ever before to inspect the multi-ton boulder positioned in lunar orbit. For this mission, humanity will travel over 300,000 miles into space to touch a fraction of the cosmos. The mission will test new spacesuits and systems, while the astronauts select and gather samples from the primitive multi-ton mass. Other missions of Orion and SLS in the area between Earth and the Moon will conduct exercises in advanced life support, deep space habitation, orbit changes, and staging for assembly operations, all needed for future human missions to Mars. Just as looking back to Earth from the Moon during the Apollo era shaped how we perceive our place in the solar system, watching Earth fade to a small blue dot of light as we travel farther into the cosmos will surely enhance our understanding of the universe. Join NASA as we view new horizons, Work with us as we push forward to develop new technologies and innovations that will benefit humankind and take us beyond the boundaries of human exploration. Join us on NASA's journey to Mars.